Hey everybody, welcome to another episode of Catalogs, Manifests, and Metadata. Oh my. This is episode number 4. Last episode we talked about what are table formats in general. So now we're going to drill down to the next level and talk about what specifically is the Apache Iceberg project and just kind of talk about it from a sort of a high level. So Apache Iceberg is one example of a table format. Again, these are basically formats that create a standard for how you write a layer of metadata over data files on a data lake. So essentially, it's just a way to bundle data in your storage and say, hey, this bundle of files in your storage are one singular data set. That's essentially all it is, but it also collects many statistics on that data set that can help query engines better search that data set more intelligently and quicker and faster and cheaper. Okay, now Apache Iceberg is really cool because the way it tracks the data is that essentially it uses a metadata tree. And generally, there's a top level file called a metadata.json, and again, each of these files will kind of get their own episode in itself, just to kind of talk about what makes them special. But you have a metadata.json that kind of talks about, hey, this is the table. Okay, this is how the table schema is the table's partitioning. So this is how the data is kind of organized, and here are the different points in time that the table has existed, the different snapshots. Okay, so generally that's always going to be the place where a query engine begins understanding the table, and usually they're able to discover, because oftentimes a table, every time it changes, it creates a new metadata.json. So you might look in your data lake, in your storage, and see like 20 metadata.jsons for the same table. So how would a query engine, let's say something like a Dremio, know that, hey, that's the one I need? Well, this can generally happen in one of two different ways. You either have a service catalog, as I generally refer to it. This just means a catalog that tracks your tables, but is a running service. So this could be a database or some sort of REST API service that's backed by a database, but it's something that actually is continuously running, and the query engine can then request and say, hey, I need to know which is the right metadata.json for table A, and will send back a response saying, this is the right one. Okay? Generally, you're going to want one of those because generally these running services generally have different mechanisms to prevent sort of two writes trying to update the same table at the same time. So you get certain guarantees that you may not have with certain storage layers like S3, because the alternative, which is sort of using sort of the file storage as your catalog. So you're not running a service as a catalog, you're using your storage as a catalog. You track it through a file. And again, actually, I'll just do a whole episode on the whole catalog. So that'll probably be the next episode because that's a big conversation. Okay. So again, you have the catalog that tells you which is the right metadata.json. The metadata.json tracks all the different snapshots. So then I can find the snapshot of the table, so which version of the table that I'm looking to query. And then you have a manifest list that basically lists all the manifests, each manifest being a group of files that are part of the table at that point in time. Okay, so at any point in time, the table is made up of a bunch of different files, and those files are grouped into manifests, and the manifest lists those manifests. Okay, the terminology sometimes gets a little word mouth jumbly. Okay, another way you can think about it is manifests are groups of files, and a manifest list is a group of file groups. Okay, so essentially it's just aggregating at a higher level. And then both of those layers generally have stats to help determine, hey, which groups do I need to look at? Which individual files I need to look at? Allowing a query engine to kind of look at it more deeper. So that's fundamentally what Apache Iceberg is. But, a lot of what I just said, being able to skip files, being able to recognize a data lake table, these are things the other table formats do, like Delta Lake and Apache Hudi. What makes Apache Iceberg particularly unique is that the partitioning is sort of tracked at that metadata.json level. And this enables a few things. So the individual list of files and the individual and those manifests, they don't actually have to sit there and list what the partition is. They just generally refer to what basically each partition gets an ID that's in the metadata.json. So we can say, hey, these groups of files were written with partitioning scheme 1. These group of files were written with partitioning scheme 2. And because of that fundamental design choice, you can actually have multiple partitioning schemes over the life of a table. So you have sort of this new paradigm called partition evolution, which is not even something you find in a lot of databases. Oftentimes, if you change how a table is partitioned in anything, whether it's a data lake or a database, oftentimes what you're really doing is you're rewriting the data completely. So it can be an expensive operation. Okay, this ability to incrementally change your partition can really reduces the cost of experimenting with how your table is partitioned to get better performance, which is a really big pro. And again, we'll probably have an episode on that to go more deeper into how that works. But yeah, and then there's also other things that, because so much is tracked with metadata, and the partitioning is all sort of a metadata operation, none of it has to do with sort of how the files are physically located. You can do a lot of really cool stuff with partitioning. There's another feature called hidden partitioning that allows the execution and consumption of partitioning to be a lot easier for data engineers and data analysts. So you have these really nice so Apache Iceberg does not only allow you to recognize table and give you some nice ergonomics around working with data lake tables. It gives you performance and ergonomics, which is kind of two things you need. You need something that gives you speed, but you don't want something to give you some speed with too many knobs to twist, with too much complexity, that you're pretty much still having to do a lot of work and thinking through how you, much more work than you probably really need to optimize most of your tables for most use cases. Because you can have a lot of knobs, so you can perfectly optimize it for every use case. But then what happens is the common use cases become overly tedious to configure for. And this is where Iceberg kind of really, really hits well, in the sense that it's built to be flexible, so that way you can optimize for niche use cases, but the way it naturally works really lends into sort of what you need most of the time. So that's pretty cool. So that's what Apache Iceberg is. It's a table format. We'll start getting more details into the features and structure of Apache Iceberg over the next several episodes. And again, you can always read the book Apache Iceberg, the definitive guide. Okay, so again, I did co-author the book on Apache Iceberg. Apache O'Reilly's Apache Iceberg, the definitive guide, which was a journey to write, but it is will be available very soon in early May. So, but you can already pre-order on Amazon. So if you want to learn a lot more about Apache Iceberg through a physical book, do pick that up. And if you ever cross paths with me, I'd be more than glad to sign it for you. But I'll keep doing these episodes so you can keep learning more and more about Apache Iceberg, and then eventually we'll get into other open source projects like Nessie and Apache Arrow, all in to give you a deeper understanding of sort of this really interesting sort of open source data lakehouse space. But with that, I'll see you all in the next episode. Have a great day and enjoy.